we're all excited about IIoT and Industry 4.0 and IoT and M2M and I guess more the Internet of Everything. So what I thought I'd talk and focus really about today is what are we doing to really take all these legacy systems out there and how do we connect these things up with the magic Internet of Everything? So with that, I'll first start off is, well, what is the OPC Foundation? Probably everybody in the room knows, but I want to center on this for a reason because it's all about what I prefer to say as we're developing the Internet of Things and developing the technology. It's about a community of suppliers and end users collectively working together, essentially collaborating. Many organizations partner with the OPC Foundation. I'll highlight some of them later on. Essentially to bring quality products to market that build solutions for end users, okay? And that's the bottom line. And working with system integrators essentially as the conduit to the end user community. We also do a lot with compliance and certification. So when you think about building an OPC product that actually is linking all these legacy systems to the IoT, they're going to be certified products or quality products. They're secure, they're reliable, and obviously very focused in interoperability. From a foundation perspective, we're not just an organization in North America. We started in 1995. We're truly international. We have an office in Scottsdale. We have an office in Germany, an office in China, an office in Japan. And we develop international standards that are recognized by IEC. We work collectively with IEEE, we work with ISO, and we work with ISA to develop really specifications that solve interoperable problems. So I want to talk a little bit about this thing called Industry 4.0 because Europe happens to be one of my biggest market opportunities. And we talk about this whole naming of Industry 4.0, and it's really driven from the 4 stages of the Industrial Revolution, where the 4th stage is really all about smart automation. And this whole concept of smart automation is really the driving force behind the IIoT. You know, it's all about the best in interoperability. It's about taking these connected devices and connected application and being able to actually communicate together in a very seamless, interoperable fashion. So we talk a lot about that. So the Industry 4.0 activity that's been sponsored in Europe that is now being carried over into North America and China and Japan with their own permutations of this is really all about vertical and horizontal connectivity for moving data and information from embedded systems all the way into the cloud. And OPC UA is proud to be a very important part of this reference architecture for Industry 4.0. So when I talk about Industry 4.0, then I want to talk about the Internet of Things, which is the industrial Internet of Things or the Internet of Things period. A lot of it is driven from our consumer electronics. You know, we all have, and I won't put my I don't call it a smartphone anymore. I call it a smart device. You know why we call it a smart device? Because all of our children and grandchildren, they don't use this thing as a phone. They use it as an information repository. They surf the internet, they text, they connect up to social media. They do this as their information exchange. And you think about this, that's what an IoT device is all about. An IIoT device is really about, now I can do this with the plant floor. I can do this with my chemical refinery. I can do it with my subsea drilling machinery and take a look at this stuff as I'm pumping oil, and I can actually look at how the system's working. So with OPC UA, we not only solve the problem of connectivity of the Internet of Things, we do this in a secure fashion, and we do it via information modeling. So my colleague Dennis is gonna come here to the stage later on. He's been dabbling with a lot of end users for a while, both in the pharmaceutical and the oil. But essentially, we take other consortiums' information and allow the OPC UA architecture to essentially exchange this information between devices that typically can't talk together. And that's the concept of this information modeling of what we're trying to do. So when we started OPC in 1995, I spent most of my career at Rockwell focused at discrete and focused at factory automation. The reality is OPC now is really all about not only industrial automation, it spans lots of other domains, including building automation, including security, including anything to breathe with opportunities for automation in a multitude of domains. And that's an exciting part of this as we listen to the gentleman from, Don Petrusek from ExxonMobil and some of the things that they're doing and how they actually want to link up many systems together. Not only do they want to link up their, the oil system, they actually want to link it to the building systems as well and have all this information contained and being available on a widespread basis. So we're talking about OPC UA as the Internet of Things standard. Okay? And what we're talking about is we're talking about this whole concept of connectivity and information and data from the embedded world all the way to the, the cloud. Many of the organizations we partner with are in that circle there. Essentially, I'll work with anybody as long as they have an information model, and then we'll help them provide a secure, reliable way for taking their information and being generically consumed by other applications and devices that typically don't understand this. Usually what I do is I talk about this information modeling because I talk about digital imaging. I know my good friend Craig there takes a lot of digital photos, okay? Craig, you've got some Aunt Ethel, and your wife said, find me all the pictures of Aunt Ethel. What would you do? You'd say, you gotta be kidding me. Scroll forever, right? Well, I talk about metadata. And one of the things you can do now, when I talked about this 5 years ago, there was no technology called facial recognition. Facial recognition is edge now, so once you find one picture of Aunt Ethel, it'll go surf your hard drive, search every other single image on your drive, basically, looking for matches for Aunt Ethel. And actually, with every digital image, it stores metadata. It stores information about who's in the picture, what color she wore, what are the other things, when the picture was taken, where it was taken. That's metadata. So when I talk about information and a lot of the things we're doing, now imagine I've got a valve. I got this valve in my process plant. I want to know all the places that valve is used. An interesting way I can do that, with that valve object, metadata is stored. And that allows me the ability to know all the different graphics it's in, all the different alarms it's in, who opened and closed the valve, when they opened and closed it, were they allowed to open and close it. This is the type of stuff that we talk about when I talk about information. And I promised Joe that I would do my, my 4-hour presentation in 20 minutes. So that's what I'm trying to do. So with that, I want to talk about why we're paving the way to the IoT. Essentially because we've got a lot of different manufacturers out there and suppliers that are actually looking at the UA technology that's very scalable. It's a service-oriented architecture that essentially is platform independent and allows them to embed it in a lot of different devices and applications where traditionally they couldn't go before for interoperability. Now OPC UA not only becomes a mechanism for producing data, it allows other applications to consume that data, and then they can take that data, who consume it, and turn it into information and serve it up to some other set of applications into the cloud. So essentially, this is what we talk about when we talk about IoT. A very connected world. I want to have connected information. I want to have information that's secure. I don't want, these two colleagues sharing information that they don't want to share. There has to be a level of authentication between them and decide who can share that information. I just don't want to browse the internet and find out things about my plant that I shouldn't know about. That's the whole connection of why we're providing secure, reliable interoperability for the IoT. When we started OPC, essentially we were building it where we did first-tier visualization. We used to build these things called OPC servers on Microsoft platforms, and essentially this provided the first-tier visualization applications a standard way of getting that data. With OPC UA on the PC, you can now actually you can still have that OPC UA thing on a PC platform, but now I can enable a variety of other applications on different things across the corporate firewall. And the same thing is the OPC UA server then essentially communicates down to the device. More importantly is because OPC UA is very scalable, we're actually looking at putting a lot of these things where the OPC UA technology is actually on board in a lot of these embedded devices. So whether it's a PLC or a sensor or an RTU or some motor or some level of smart meter, UA can be the conduit and essentially provide information up to the higher tier applications, whether they're HMIs or historians or MES or even up into the SAP level, eventually communicating that information. So why is UA IoT? Okay, why is it more than connectivity? Because first off, it is about connectivity. Second thing, it's about what I call data context preservation. And third, I talk about security. So when we talk about connectivity, I talk about UA resides on any platform that we know today and will know tomorrow. It's totally platform independent, it's very abstract. It's the whole concept of what your friends at Lockheed and ExxonMobil are preaching about. We want to have a truly open system that has timeless durability. So independent of the operating system, these are the operating systems today. What are the operating systems tomorrow? I don't know. But UA will run on those operating systems deliberately. So it's about the connectivity standards and different protocols and having plug-and-play interoperability. Data context preservation I talk about allows me to take a complex information model in some device and allows me to be able to take that data and be able to consume that data by some other application that doesn't even have the foggiest notion of understanding what that is. So that essentially maintains the context of the information and allows an application, for example, like Microsoft Excel, to look at a valve, get all the information about the valve, get all the information about opening and closing the valve, without having any sort of predefined notion of what the valve even is capable of sharing. And that's the data context preservation aspect of OPC. So the other thing is, security is very important. It's one thing to say two devices are connected together and I can share information, but suppose I don't want to have that information shared. I want to restrict who can change the set point on a given system. I want to restrict who can actually read the data. OPC UA puts security in. It's been widely accepted by both the IT and the OT that Joe was talking about earlier. It's accepted by the National Institute of Standards. We got Industrie 4.0 rallying around saying the OPC UA provides a secure interface for that. So if you remember anything what I talked about today, OPC UA is intended to be the Internet of everything, essentially bridging the gap between Industry 4.0, IIoT, and the M2M world. Some of the key features is it's platform independent, it's highly scalable, we build in security, it supports basically all the legacy systems that Joe was talking about before. I've got a huge installed base. My friends at ARC tell me there's, 45 million different installations of OPC. That's a lot of different OPC products out there. And with OPC UA, we have to be able to have this way from an IT and OT perspective of moving all that data and information from those legacy devices. So it's a single solution from the embedded world to the enterprise. Like I said, it builds on the existing world of OPC, and it also allows a very flexible information model. So you can find Ethel, or you can find all the instances of where the valve is being used in our complex system. Our information modeling architecture allows all of our consortiums essentially to build their own standards and allow OPC UA and allow Microsoft Excel, for example, to be able to consume information about things they typically don't know anything about. And this is all built into the base architecture. I showed you that circle, so we're active in the oil community. We have a lot of partnerships with a lot of oil companies and DCS vendors and subsea vendors, defining an information model. We're doing a lot of work with the smart grid. We're doing work with 61850. A lot of different organizations modeling their information in what's known as that specification of information model to allow OPC UA to be the mechanism for passing that data. So this is kind of summarizes a lot of that. In addition to doing what's known as the client-servant architecture of OPC, we're actually extending the architecture to support what's known as publish-subscribe. This, again, is an easy thing for us to do and allows us to preserve the investment that my vendors have built with existing OPC UA to have plug-and-play interoperability into a lot of other different environments, supporting a variety of different protocols and information models. So the last thing is vertical integration. I already talked about this briefly. An OPC UA server serves up data to a client. Client becomes a server, takes that data and turns it into information. And that's the whole concept of total interoperability. So what is UA? What is OPC dedicated to do? I'm interested in collaborating with any organization to take their information, provide a convenient way of modeling that information, and then providing the necessary services to allow this data to be moved from the embedded world all the way to the enterprise. So we're becoming the industry or the Internet of Everything standard, actively supporting IoT, and Industry 4.0.